There's a little thumbs up there. Yeah.
Okay.
Right, thanks for festive turnout. It's good to see a lot of you guys. I haven't done an in-person presentation for a while, so bear with me. So today we're going to talk about common safety methods. So this particular common safety method, there are various common safety methods if you look at the actual legislation, but the one that we are looking at today is called risk evaluation and assessment. So common safety method, they only apply or it's to the railway sector. Do I have
Yeah.
do I just
press right,
right?
That's it. Yeah,
right.
like that. There you go.
Right. Okay. So a little bit about me. So my name is Ki Cheung. I'm a chartered civil engineer. I currently work for a high-speed rail solutions, a small company which specializes in safety assurance and typically CSMs, NTSN, and things like that, integrations. And Jack is here as well as one of our principal engineers. I'm a little bit of comfort. So back in the day, being a civil engineer, I love bridges, and that's all I wanted to build. And actually, I was an Atkins placement student, and I joined MOPS as a bridge designer. That was my background. And then I worked for Network Rail for about 10 years. But during the time that in Network Rail, so I undertake the role as integration managers, and then subsequently DPE for predominantly quite large complex railway systems and projects. So I've got to know a lot of different systems. So I come to understand that railways are being a systems rather than just building a bridge or building the tracks and things like that. So this is what we're going to talk about today. Oh.
There's a little bit of a lag. So just
right. Okay. Have I? Right, let's go back to the topics that I would like to cover today. So what is CSMRA? Some people call it CSMREA, CSM, or most of the time that we talk about it on the railway, we tend to just call it CSM. So let's get to terminology, right? So I would like to talk about the key duty holders with regard to CSM, and then the actual risk management process. So CSM in essence is really an engineering safety managed process. So what are the safety lifecycle deliverables? There are mandatory deliverables within the CSM regulations itself, and also there are extra deliverables mandated by Network Rail. So a lot of them are main clients. It's fair to say that it's Network Rail. I'm sure you might, I think Simon's probably working for Transport for Wales, and so they're kind of equivalent to Network Rail in a sense. They are infrastructure managers. So we'll look at the when we come to the stakeholder, we can look at those. And so what complying with CSM RA means to you what is your role if you feel like you are not the key stakeholder? That's what I would like to get across, and a little bit of Q&A and discussions. So before I start, can I have a show of hands of your experience and with CSM? Yeah. Okay. Yeah. Do we have mostly engineers here, design engineers, or?
Yeah.
Everyone is the same.
Okay. Right. Okay. Oh, there's a show of hand online as well. Thank you. I think it was Robert. So CSM really, as I said, it's a framework for essentially risk assessment. What it came about with, I think it's actually way back before. So when we were still in Europe, yeah, we want to, the European wanted to promote interoperability. So it's like each country can sell the services to each other, the components and services as well. So one of the problems that they encountered was, well, how do I know how rigorous your safety assurance is if everybody was doing different things, right? Obviously, let's say, for example, if you're bringing in a train, you could so obviously see the train's not going to fit or something like that. So from a procurement perspective, it's quite difficult for them to judge, who's doing what. So one of the solution was to bringing out the common safety method. That's why there are different common safety methods. So you have monitoring. So I won't go into them because I know nothing about the other common safety method. I'm not gonna lie. As we know, in 2019, it's been amended post Brexit, so we didn't really get away with it because it's such a good framework to use for safety assurance. So it's been rebranded under the Rail Safety Amendment regulations. So it is still the CSM regulations. So it applies to when you are making a change to railway infrastructure. Not just railway infrastructure, sorry, railway to the railway. It covers technical, operational, and even organizational changes. When we talk about changes, what does it mean by change? Because I actually teach an 8-hour course. One of the big questions that I ask is because the terminologies that are being used is a change. What is a change? It's not really a change because I am building a new station. But if you look at the railway system as a whole system that extend the whole, European network, you're adding a station, you are changing the network, you are changing the systems. So anything that we change is a subsystem itself, right? So that is a change. So it's I'm building a brand new line. Well, it is a change to a network in a whole scale sense. So that is the difference. And then when we talk about organizational, for example, Network Rail, as we know, every 10 years, they have a major reorg to look at, right? And devolution and devolution 2, and I've lost track now. So every time when they do something like that, it is a change to the railway because us, you and I, and everyone on the seat, if you are working on a railway system, you are part of the subsystem. So you are a subsystem itself and part of the system. So if Network Rail make a major organizational change, we want to be sure that everyone knows about their responsibility, how the safety assurance is discharged or offload or whatever. So it needs to be assessed as well. For example, when is it Andrew Haynes do the devolution as part of the PPF. So we were broken into different. When I say we, well, I used to be we, in different regions. So that had to be assessed. Using the common safety method just to make sure Network Rail as a whole, they still have their strategy together, and then there are their SMS, which is the safety management system under ROCs, still valid. So I won't focus on so much about the operational and the organizational change today. So technical changes are kind of my expertise. So we talked about the duty holders. The duty holders are, so essentially, unlike CDMs, there are 5 duty holders. So, right, I think so, right? Me and Jack had this little debate. And 7? All right, okay. So in terms of CSMRA, there are, in terms of the name duty holders, there are only 3. So you have the proposer, you have the assessment body, and what we call the actor. So actor basically is really everyone that have the interface with the change. Typically, who is the proposer? The proposer is the person or the entity proposing the change. Typically, well, in CSM, it's quite strictly speaking, like who can be the proposer. They are the infrastructure manager, the entity that in charge of maintenance of a fleet. So, if is Hitachi maintaining the train fleet or something like that? Yeah, so they can be, a proposer as well if they're changing the configuration of their trains and things like that. And then the manufacturer of signaling system, for example, Alstom, Siemens, and they can be proposers as well. So they have the ultimate accountability of ensuring compliance of CSMRA. And then we come on to the assessment body. This is a formal role that you need to, so the proposer has to appoint an external and accredited body to become the assessor for the CSM compliance. So this assessor, they assess the safety as well as the quality process of how CSM is being applied. Not only ticking the box that, yep, I've got all the deliverables, I've done my hazard, I've done my hazard, you know, things like that. So they look at the quality process to make sure, obviously, it needs to be a quality product and quality process throughout, you know, the life cycle of the project. So they will assess that as well, not just, well, here you go, this is my hazard log, and this is my recorded meeting for the hazard. And so they have duty to produce a particular deliverables as well. So we can have a look at that a bit later. They do not need to be subject matter expert, but obviously it helps if you're doing a signaling, you know, project, you know, having an assessor, you probably have less questions, but obviously throughout the process, you should be transparent and ambiguous, you know, not leaving any open point for questions or interpretation. And then when we come to actors are really essentially is all the parties that directly or indirectly, contractually, indirectly involved in the project. It could be your subcontractor, all the project engineers, you know, all the design engineer, subcontract, you know, whoever's contributing to the change, even commercial managers, anyone that, you know, have interface with the project, they are actor. If they identify to have an action, they are an actor. So this is the process itself. This is a bit, I'll, if you like, I can send out a copy of this later, you know, just for reference. So this is the essence, right? This is the gospel of how you apply CSM. Like I said, it's just a framework. CSM is, I know it's a regulation, but it's branded as a regulation because they want to mandate it without any argument. So we look at it. So there are 7 steps, I think. Let's see if I can count. Right. The first step, the first step here at the top, it's called the significant test. So make no mistake, right? I'll come on to that later. So CSM full compliance, CSM, essentially, you will only by law, you only need to comply if your project is deemed or assessed to be significant, right? If you're not significant, doesn't mean that you can forget about it. We'll come on to it. So, but make no mistake, because unless you assess it, how are you going to be sure or justify that your project is significant or not? So any of the railway project has to go through the significant test first. So in a sense that it actually applies to every project, if you see what I mean, because you need to apply the significant test. So that's at the top. Is your project or your change significant or not? And then we'll come on to defining the system. This is where the main deliverable is the system definition. But prior to the system definition, it is actually very common, or it's actually, it's almost like a goal without saying that you write a preliminary system definition that will inform your decision making for the significant test. We'll come on to the test a little bit more detail, don't worry, a little bit later. Right, and then the third, so once you determine that it is actually significant, you produce your system definition, which is the, you know, just setting out the boundary of your change, because it's quite easy to, it's a bit like it's a bit like a scope creep. If you don't clearly define your boundary and what you're looking at, suddenly you find yourself looking at, items that it's got nothing to do with your project. And then, so you do the hazard identification after you define your boundary, and then this is the main, the main part. This is, quite an involvement part of it is the risk analysis, the evaluation. It's really having the hazard identification workshop. And has anyone come across a CSM hazard log. Yeah, quite a few. They're not just, then they don't quite look like the CDM, designer risk assessment, just on the back of your form B, or just like 2 pages. It's quite an undertaking to manage a hazard log. So on a big project, you could have hundreds, if not thousands, of entries of hazard. So you have to apply the method to rigorously analyze each of the entry on the in the hazard log. And then the main point of that is you derive your safety requirements. That's how you're going to mitigate the risk that you have identified during your process, your identification process. Right? All of that, it's bound by your hazard management. So this is typically you manage that using a hazard log. And all of this, except for the significant change test, is subject to assessment by the assessment body. I was going to remove it comes out a bit slow, right? Okay, so the significant test. You know what? I'm gonna do this. Right, the significant test here. So as I said, every project, especially if you're doing network rail, even transport for Wales, if you are changing the system, you want to assess it. And you don't want to be later on challenged. Well, I think your project is significant. Why don't you apply it? Yeah. So you will do the significant test and go to NRAP or the safety panels. Whoever, is it still NRAP in transport for Wales?
AWAP.
It's AWAP.
Yeah, AWAP, right? Okay. So that is, they are your ultimate safety panel in the client organization. So they I presume they will have a process. So Network Rail have the process. The Network Rail's main standard is the NRL2 RSC /100-02, right? Okay, so there is a very detailed process, how what you need to go through and things like that. So you will write your justification, apply the test, and then apply to NRAP, and then you tell them what you think it is. You don't go in and ask, could you make a decision for me? No, because the project team are the project expert. Right, okay, so you've decided someone wants to do a project or a change, right? So someone, typically at the very beginning, it will be the sponsor or the development manager, pull together a preliminary system definition. At this point, it's obviously we appreciate that not all the details will be there, but someone will have quite a conceptual design, early stage design that for someone able to pull together a preliminary system definition. So that fits into the change, and then so you do that. So first of all, you ask yourself, is the change safety related? Yeah, if I were just changing some office equipment, I mean, obviously you can argue that it's safety related itself, but that's it. Really, does it impact on the railway system safety? If it's not, then you can almost put it to bed, at this stage. But do not just do nothing. If it's deemed to be non-significant, yeah, you need your decision to be ratified by NRAP or ARAP or whoever the system safety panels is, in the client organization, and you want that piece of paper and file it safely. You don't want to be challenged later on. Yeah, recall your decision, and then at the same time apply the company safety management system. So I'll come on to that a little bit later. The company safety management system is bound by ROC. So ROC want every company to have a safety management system. You need to demonstrate how you're managing your safety within your organization. If at the early stage you decided it is safety related, then you got to ask yourself, 6 questions. Right, I'll just read out the questions. Is it what's the is the change low? Or I think I've kind of written it in a reverse, sort of way. Is it low failure consequence? What is the failure consequence? What about the novelty level? What about the complexity level of the change? And is it easy to monitor? Can the change be reversed if you don't like it or it doesn't work? Yeah. And the additionality as well. So what that means is, so sometimes if you look at your own project or change on its own, it's probably not significant. But six months ago, someone else has actually changed something else in the same project. It's quite common in network rail, isn't it? Well, I change a bit, you change a bit. Right, let's chop it up because of the funding issue. So, as a project, you have the responsibility to look at some of the changes quite recent. How do they, come together? If you change, some section here or some change here, how are they interrelated? Maybe if you add all of these borderline, change together, they actually become very significant. And then, so if all the answer is yes, oh, that means it's low, it's not very complex, and then it's not significant. Then you can just apply that. But if the answers are they're high failure consequence and quite normal, and that means it's significant. That is when you need to apply the CSO vigorously. The first thing that you do, or the proposal should do, is to appoint an ASPO. Yeah, you want to enroll the ASPO right at the beginning. You don't want to, have questions to be asked. Well, did you do that early on in the process? Right, okay. The system definition mentioned before, really, there are 2 objectives of the system definition. Is to provide sufficient information to facilitate the hazard identification workshop. That's very important, because so having looked at that, if you were invited to a hazard identification workshop, sometimes, I don't know whether you've been to one, there's a lot of discussions going on. Sometimes you could, it can get a bit out of hand, not out of hand, but kind of move away from the subject. So having a system definition that you define your boundary, what your systems is going to be. And also the system definition is the piece of document. It's an evolving document. It's it's subject to change throughout your life cycle. It's not something that, oh, I wrote it and then just okay and use it at the workshop at the beginning and that's it. It's so every time when you change, so there is a design change or there's a significant change, you should go and revise and update this system definition, because that system definition eventually should form part of your handbag to tell the next project. So when someone can pick that up, it's a bit like a health and safety file. Well, I started putting in a health and safety file so that the next project can, see what's the final configuration of the change. And then you have the, so the second stage is you start conducting your hazard identification workshop. So you need to identify all the foreseeable hazards. So sometimes it can be quite trivial. If you can think of it, let's note it down, because there is actually a mechanism to kind of, well, at least I thought about it. I can put it to bed. I don't need to talk about it. Because so you need to vigorously identify anything that you can think of, big or small. It could be even, well, is someone going to, I know paper cut is a bit pushing it, but if it's something really you think it's quite minor in nature, but at least we have a good talk about it, we can filter these out. That's called broadly acceptable hazard. So it is so unlikely to occur, so insignificant in its consequence that further effort in reducing the risk is not reasonably practicable, like a paper cut. Right, and a meteoroid impact. I mean, yeah, you could say it's a hazard, but how are you going to mitigate that? Yeah, not running. Right. So you have that. And then the next step that you come to is the risk analysis and evaluation. So CSM mandate this process is not an option. You need to do this as a step, but what they don't mandate is the tools that you're going to use it. For example, you could use Famika, you could use Familiar, you know, any of the, you know, tools that you can think of, or you can use it. So CSM doesn't mandate any tool, but the process is mandated. So you have what we call here, 3 criteria. They are called the acceptance principle. First, you have code practice. The second one is called a similar reference system. Third is explicit risk assessment, right? In reality, about 90% at least of the hazards being identified, they can be mitigated by code practice, by following, you know, code practice. But in the CSM process, it's quite it's a very detailed what is deemed to be code practice. It needs to be well known. You can't just say, well, yeah, my principal engineer wrote this little guide here, but we're all doing it in our company. It's got to be safe, right? You can't do that. So typically, Network Rail standard will be a good code of practice, British standards, and all the BSEN standards, and even the laws. You know, you can cite you can cite CDM, or, you know, any of the LOLA regulations or confined space. If you can, you know, project can demonstrate that this is what they're going to comply, that can become your code of practice for mitigating that particular hazard or risk. And then similar reference systems. So this is actually quite difficult to use, because you could say, oh, well, I'm doing electrification project. Surely, you know, Great Western did one a few years ago. I could just, yeah, the whole thing is the same, but the route alignment is different. So it has to be quite exact in, you know, in terms of the you know, the sort of like the climate, even the geophysical, so all the aspects. So it's actually quite difficult to apply a similar reference system, because it's quite a good undertaking, or big undertaking, to prove that, well, my system is exactly the same as the other one, or very, very, very similar. You know, just because the speed is different, then it wouldn't be the same, would it? And then the third one is explicit risk assessment. And it's when you can't use code practice, you can't use similar reference systems, and then you go down the route of doing some explicit risk assessment. So with the explicit risk assessment, you can do quantitative and qualitative. It's quite involved. I'm not myself a risk engineer myself, but my colleagues are. So again, you can use a lot of Famika. What are the other tools that I've seen some? So I've commissioned one myself years ago. So they did a lot of a huge cost benefit analysis to justify the risk of what we're going to do. We came to the conclusion. So we spent about 50 grand doing that risk, and then decided, well, it's not a risk. We're going to put it to bed. But at least, but then that saved, you know, a few £100,000 in the long run. And you need to, so then you evaluate, you know, once you identify this. So for example, if you're building a bridge, the bridge might collapse. Oh yeah, I know what I'm going to use. I'm going to design it to Eurocode. Is it acceptable to use a Eurocode? Yeah, I think so, right? Then you think, so you accept the risk. That, right, okay. Any questions? Sorry, if I'm talking too fast, I get really excited. Any questions online or here?
Just a quick one on the reference system. Could you use
Yeah.
like a very small part of the system? So not the whole project, but maybe like a very detailed small part.
You can actually.
Yeah.
But then again, it's, you know, down to your justification that you can justify,
Yeah.
because we, you know, when we do a lot of it, so I'll probably skip some actually fundamentals. So hazard, typically happens at interface. If a chair is there, you don't move it, it's not going to cause any problem, right? It's only when if I started walking about or there are a crowd here, then it might trip someone over. So it's the interface. So if you're just applying a small section, then you need to be able to talk about your interface, why it doesn't matter, why it's okay to use that. So like I said, you can, but you need to be able to justify that.
How long does code of practice have to exist before it can be considered a code of practice? So if we had a brand new standard introduced by Network Rail, we're at issue 1, date of enforcement December 2023. How long does that have to be in place before it would be considered to be a code of practice?
I haven't come across that question. I'm gonna make it up, but I'll give my own opinion.
It's an extremely loaded question.
It is.
Apologies.
No.
I've obviously got a specific standard in mind.
Yeah,
Yes.
I think it's very valid. You will hope that they've gone through very, very vigorous.
Oh yes.
Yeah. Okay. So it is publicly available. Yeah.
Well, it's available within the rail industry. None of Network Rail standards are publicly available.
They are actually. They are free. You can apply your own login. Anyone can actually apply now. Yeah, they are free now. It's been like that for a couple of years. Yep.
It's not going to apply for his own personal.
You can actually. So there are two main criteria: is they need to be publicly available and they need to be accessible by the ASPO. Yeah. So if they are, but obviously the ASPO will have to decide. Well, in this case, they might have a little job to do. So so someone will have to give assurance that that publicly available standard has been through all the quality assurance, in its own safety assurance before it's come out to the public.
Yeah. Okay.
Yeah.
There was a hand up, but I think you probably answered the question they were about to ask. So it might be best, easier to manage if we do questions at the end. If
Okay.
that's okay.
Yeah, sure. Right. Okay. So safety. So we do all of that. We do all of that, the system definitions and then the identification. It's not because we just want to highlight the hazard or the risk. More importantly, we want to know how we're going to manage it. So to manage it is we're going to derive some safety requirements. So there are various terminology in the standard itself. So you will see a terminology is called safety mitigation. I think that is a more sort of more well-known, more conventional terms when we come and talk about how we mitigate risk. So in the CSM process, the CSM requirements are the ones that you have chosen to mitigate the risk. Yeah, the mitigation are the ones that, oh yeah, we can do that too, or we can do that too. But the requirements are the absolute non-negotiable chosen mitigation that you have to apply to the project. For example, you have identified that going back to the bridge, I am going to just make sure that the loading is correct. I'm going to apply Eurocode. Can't remember, sorry, I haven't been a bridge engineer actually for a long time. So the designer needs to be aware that when they're designing this bridge, this is the code that they need to demonstrate that they have complied to. Or if they're, sometimes it needs to be, depending on, obviously the hazard and the risk, sometimes it's necessary to actually specify the actual clauses and that can satisfy or mitigate that particular risk. It's no point, not good just saying Eurocode 2 or Eurocode 3, which particular clauses. So it really depends on the hazard being identified itself or the risk that you're trying to mitigate. So you apply all of that, and so yeah, essentially that's the requirement. So sometimes the requirements can be, you will find, for argument's sake, the requirements could be if there is a signal sighting problem that has been identified, what do? Can you redesign the signal, or could you reposition it? But you find that you can't actually reposition it. You need to introduce a banner repeater or something like that. I'm not a signaling engineer either, correct me if I'm wrong. But then again, you actually now introduce, so sometimes you can actually, as part of your introduction of the safety requirement, you are changing the system again. And that's why this is a really important point to note. The CSM process is continuous, it's iterative. You don't just do it and put it to bed. And going back to the point that the system definition needs to be updated. So for going back to the banner repeater, so now you introduce a banner repeater that it wasn't there in the original design. So you change the system, hence you need to go back and change your safety system definition. There you go, just a reminder. Right, and then you need to demonstrate that you have actually complied with your requirement. So this is the demonstration. It's a bit like a V&V exercise, the verification and validation exercise. So you can have, so for example, a lot of the times that you produce the Form E, if you're not on a network rail project, and the as-built drawings, but obviously you need to be sure someone needs to sign, the CEM has to sign that to, to say that the as-built drawings are correct, and things like that. So you need to be able to demonstrate with evidence. You can't just say, I've done it. The ASBO is not going to accept that. I've done it. Tick the box. You need to produce the evidence. And the ASBO will actually, they are not going to, so if you have 3,000 entry, they're not going to look at all 3,000. It's proportionate because ASBO's time is expensive. Right. And then any of the residual risk and hazard, they need to be transferred. You can't have lingering risk. So for example, if there is something that the talk you have identified as part of your safety requirement, but it's not for network rail or the project to implement, you need to transfer the risk or the implementation to the talk. So that needs to be clearly recorded. So I've got asked by the ASBO after all the commissioning and all the safety justification report post the commissioning SAR. So they are now asking, how do you know the talk has implemented that? Right, that's okay, but they're not wrong in the sense that what the CSM regulation asked them to assess or asked the proposer to do, because it's the proposer's duty to ensure whoever the recipient, the implementer of the safety requirement, is the proposer's duty to ensure that has been implemented. Or obviously, you will hope that you are involving your stakeholder at the time of, when you think that they've got something to do, right? Because then most of the time there is a bit of financial impact and stuff like that. You don't want them to be pushing back and then make the system unsafe. You can't just leave it open. So, so I mentioned a hazard record earlier. It doesn't look anything. It doesn't look anything like your standard sort of design and risk assessment. So the hazard record itself, it's a very simple tool. You identify the hazard, you identify how you're going to mitigate the risk. Simple as that, right? But what we want to do is, because we're being assessed that you are applying CSM diligently, you want to be able to build up a picture. So you want your hazard, wherever you identify that, you want to have a source. So when the ASBO look at it, like I said, ASBO time is very expensive. You want them to be able to build up a picture without asking, well, could you tell me why you came up with that hazard? That looks a bit weird. But if they could trace back, some of the, journal, it's almost like a diary of how you come to a safe system. This is what it is. I could give an example. I think maybe some of my colleagues will remember the Reading Station, that overly, there is an overly stanchion kind of sat outside the viaduct, it looks a bit weird that they're dangling, you know, and I think my terminology is the ORL just asking, well, how can you demonstrate that you can, you know, maintain that? Well, can you not do something else? Well, maybe they, at the time, they really have exhausted, you know, I believe no engineer will do things silly. We're all competent people, right? So at the time, they might have, you know, really put a lot of effort of, you know, talk about it, risk assess it, you know, looking at alternative, only to come up with that is the best that they could, that is the most practicable, reasonably practicable solution that they came up with. But because the auditable trail was lost, so Network Rail was given a notice to justify what happened there. Yeah. So that is essentially the essence of CSM. We want to see, it's almost like a safety story, how you come up with your safe system. And these are the Network Rail project life cycle deliverables. So we are now in pace. You've got ES 1, 2, 3. Essentially, they're quite similar. So so these are the Network Rail. So system definition is a must. System safety plan. In the CSM regulation itself, it doesn't actually, there is not a word, it's called system safety plan. But Network Rail mandate that in their RSE 100.02. But implicitly in the CSM standard, it does say in the clause that said the first thing that you want to do right at the beginning of your process is you want to draw up a plan that will clearly state the roles and responsibility of all the key stakeholders. So Network Rail has interpreted or called it the system safety plan. So if you open the regulations, you don't see that terminology there. It's implicit. And then the highlights are, these are the client team need to produce. The blue boxes are what the ASPO is going to produce for the project. So system definition, it goes all the way, because going back to the point that it's iterative. It's not a static document. And the system safety plan, again, you know, responsibility can change, names can change, or the commissioning strategy can change. So you want to change that. So system, and then the assessment body remit. You produce a remit. To engage your assessment body, you need to tell them exactly what you want them to look at and what you don't. You don't have to, you know, the law doesn't say that you have one assessment body, but it's very rarely that you will have two, because they might start fighting, right? But you need to tell them exactly what, for example, you could have quite a big project, you know, going back to a great, you know, electrification project. I only, you know, this is my bridges project. I only want my ASPO to look at all the bridges. And then whereas another, you know, program manager have the responsibility for the earthworks, for the electrification, yeah. And then the ASPO will come back with the plan. It's their plan of attack. So there is expectation what you need to produce and how often do you need to liaise with them. And I will suggest, you know, keep them happy at regular interval. You don't want to hit them with your final deliverable and could you assess it? It's not just like a DRM process, but even the DRM process is all about interaction and engagement, isn't it? The hazard briefing note, typically you produce these notes just before your hazard identification workshop to give your audience, you know, a heads up what we're going to talk about. There's one note that I probably haven't mentioned is for the CSM process, what underpin the CSM process is you need competent people. So there is no, you don't need to be like a charter engineer to be a proposer or to be assessment body, but the assessment body, the organization need to be accredited. That's the only thing. But underpinning it is, you can't just have a Joe blog. Oh, well, someone just joined the project, or well, someone got that title. Let's bring him in and just, you know, say a few words. Let's pretend that we had that workshop and, you know, there are enough body. So those people that come to the hazard workshop or be party to the CSM process, they need to be competent. Not saying that they need to be chartered engineer or fellow or what have you, but they need to know what the project is about and what they're talking about. Yeah, that actually underpins the CSM process. Obviously you produce the minutes afterwards, and then it's the upkeeping of the hazard record throughout the life process. Then you have the safety justification report, typically end of option selection, to make sure that you've got a robust single options there. So you want to justify that you've done enough to come to this single option. And then you have the detailed design just before the implementation. You want a safety justification that you can go and build it safely. So when you submit the safety justification, and then this the safety, the ASBO will give you a SAR. So this is their ultimate report, that having done their observation, their assessment, they are going to write a report to say whether you need some improvement or recommendation that you change your process, or ultimately you don't want to have almost like a Cat 3 DRN comment, that type of thing, right? That's why the engagement is very, very important. Sometimes it could be misunderstanding. Honestly, you don't want to go to your SRP and say to them, oh yeah, we need to improve our CSM process. It doesn't look good. And finally, just before just before you're going to commission your system, having everything good to go, you want a doc. A doc is something that the sponsor, because ultimately the proposal will typically represented by the sponsor, will have to produce a doc. Well, obviously it's a safety engineer or DP even, that do the writing and do the report writing, but it's being signed by the sponsor to say, look, our project or system is safe. Can we go and run this train or start using this brand new stations or electrification? That's that. And then the SLP will give an endorsement letter to go ahead. So these are the deliverables. Right, when we come to non-significant project, we talked about, so CSM only apply to complex or significant project, but Network Rail has actually been a long time. A lot of people didn't know, and a lot of small projects, they still don't use it. They've actually for a long time has mandated the CSM process. It's written in their SMS, which is, like I said, it's part of their company system management system. They have told the ORL that this is the way that we are going to manage our risk, but a lot of people don't know. So, but in the latest RSE 10002, you will see, I haven't got an extra here, next time I will. So it actually tells you what you need to do if your project is non-significant. That said, if you're part of the project, even if your project is non-significant, you still is expected to apply. But the only difference is, there's a couple of differences. You don't need to engage your ASBO, so you are kind of self-certified. So the SRP is going to trust that project team. You're going to do your safe diligence, applying CSM process, or they call it CSM style risk assessment sort of thing. And then you don't need obviously you won't have a SAR because that is produced by the ASBO, and you don't need a doc. All you need to do is, if you're ready to, let's say it's a small bridge that is deemed non-significant, so you can justify to SRP that, let's say I've done all my risk assessment and all that, and then just tell them and then ask SRP to endorse it. They will give you a letter. You don't need to go through the doc and the SAR. That will be the difference between a significant project and a not insignificant, non-significant project. Right. Okay. So these are, well, I think I've gone through most of these. So as a stakeholder, I think most of you said you're a design engineer. The best part that you will do is it's a continuous involvement. The designers, I guess the most important duty or critical duty for designer is to help derive the safety requirement, because the safety typically there has a log, or all this process is being managed by a safety engineer. That is, safety engineer is not an electrification engineer or is not a PA engineer. Well, they might, but they might not. So they will typically sit down with the designer to come up with the safety requirements. And so it's a lot of help to get the designers, get the project engineer involved to make sure that all the requirements are ironed out, I properly identify and properly implemented. So I talked about the sponsors being ultimately responsible for the compliance, but obviously a lot of these duties are being not pushed, but delegated to the project engineers. No, not project engineer, well, project managers as well as the project engineers. For example, writing the system definition, it is the sponsor's responsibility, but I find myself writing it, a lot of times. And so, but rightly, they might not have the expertise because the system definition is actually quite a technical document, but they need to make sure that the system definition is there. And that a project manager, this is actually based on network rails, so it's not in the regulations itself. So these are the roles and responsibility in RSC 100-02. Project engineer, so ensure the output of discipline-specific risk assessment are included. So a lot of the time that the discipline engineer will contribute to risk assessment if we have to do that. They will produce a lot of these evidence. So design engineer, they produce drawings, calculations, and and then a contractor produced as-built drawings, Form E, testing and commissioning. All of these are evidence that you give assurance that you have satisfied the requirement, the safety requirements. You have demonstrated safety requirements. There you go. As designer, demonstration of how safety has influenced the design. Yeah, you need to be ready to justify why you design something and why you think it is safe. The contractor built it properly, right? And then articulate any change. This is really important. Sometimes you can have on-site change, but without proper process and feeding back to the designer, how do you know that change? You might think it's, oh, I'm just going to put a crank in this drainage system. Suddenly it undermines the whole design parameter. So any change I need to feed back to the design house, and sometimes let's go back to the iteration. Does it impact on the system? Does it have any impact on the system? Right, okay, that's it.
Thank you.
Hey.
Does anybody have any questions in the room before we? Hey.
I've got a question in the room.
Okay.
Sorry, thank you. That was really interesting, and I can't believe you've managed to get CSM in an hour.
Did I?
Yeah.
Exactly an hour, right?
Yeah.
Okay.
So interesting question. Interesting point you said regarding hazard transfers.
Yeah.
And having to get evidence that actually the hazard, whatever the mitigation measure is being implemented. So, for example, electrification, because I like electrification, there's then the requirement for the maintain and then start working in accordance to the green book. The maintainer might write back to you and go, yes, I'm working in accordance to the green book. What kind of evidence, and would you need to see them doing it? Or would you actually need to go back and check it periodically that they are still implementing?
I guess that will probably, so first of all, is at the point of transfer or commission, you want to see by the time that, well, hopefully throughout the process, you have engaged the maintainer. You don't just tell them, oh, here you go, I built all my project now, I'm ready to, oh, by the way, can you make sure that you do all of these things? It doesn't work like that, right? So throughout the process, you hope that you have engaged them, and then what you have done is you want to see, for example, you want to see their local instruction or their training. So what I have recently done is, so the maintainer actually have to update the whole of their their own CSM. So a lot of the method of working. So you want to see the actual method of working documents and their training record, or at least they will have a training plan already in place. But it is really quite difficult. Well, how long is a piece of string, isn't it? Do you have to go how? But at least at that point, you want to see evidence that they have put all of these measures in place. Yeah.
Okay, thank you.
You mentioned the reference system's really interesting because you said that we hardly ever use the reference system route because the reference system has to be so similar.
Yeah.
Do you think that was the intent of the people who wrote the CSM regulations was that it's so similar that we almost never use it? Or is it a classic case of British engineers taking the maximal interpretation of a set of instructions to us and maybe going too far?
That is a good challenge. But in terms of, so there are some climatic parameters that you have to satisfy. So first of all, there's something, things are very obvious that you want to look at. For example, maybe I'm just talking about quite at a macro level. You're not going to say, well, I just did an electrification project here, so I can apply the whole there. If you were looking at a component level, obviously that is a lot easier. If you were, let's say, Alstom or Siemens, working on a component level, and I arguably that a lot easier. But if you were saying, oh, I'm doing I don't know what you could do, like even implementing, quite a huge civil structure, like let's say, for example, a new bridge, right? But even, is the sighting the same? Is the traffic usage level the same? So you do really, because so if the line speed is not the same, and even the frequency of you're running the service is not quite the same, and the opening hour of the stations, is that the same? So it's a lot of questions that you need to answer, because if they are different, then they inherently.
So do you think our partners in the EU who are also operating under these regulations, do you think that are they not using? It feels like, because otherwise it would feel like no one's using the reference system route. In which case, why is it there? So do people in Europe operating CSM, do they use reference systems at all?
It's interesting because we had the presentation on Tapswell Depot a few periods ago, which is essentially a light rail kind of tram train depot. And in the absence of standards, they used other reference systems.
Right. Even though that's quite an unusual operation, right? Tram train in itself is slightly unusual. That's interesting. My feeling is that we're making it so specific that we're basically just ruling it out as an option.
Right. Okay, that's a really good challenge. So I take that as, because I'm an infrastructure, as in like an open route engineer, rather than working on which component level. So a depot is quite a static atmosphere or environment. In that case, it's quite easy, like you said, it could be easy to justify. A depot is a depot, as long as your speed is the same. And exactly. So it's probably looking at how static is it. It's because my perspective and a lot of the project that need to apply CSM, they're quite big open route project, if you know what I mean, like building a bridge in an open route. So you have a lot of different parameters that can influence, or introduce different hazards. That's why it's difficult to justify. But that's a good example. As a depot, you can, only, the depot size is different, but the maintenance activity is different, the stakeholder interaction. Then you can argue that it's quite easy. It's easier to demonstrate that they are similar.
There's a great question online.
Okay, right.
I know my glasses aren't as good. I think it's Sukesh. Are you there, Sukesh? Do you want to ask the question? I'm quite happy to read it if not.
Has the person left?
I'll ask the question.
Okay.
Is it correct to say occupational health and safety during construction stroke maintenance are CDM risks and the system risks during operations are CSM risks?
Right, okay. The way that we have been applying it, yes. But CSM is a lot of people, well, a lot of us are colleagues, and we compare CSM. It's CSM. This is CSM, or this is CDM. The draw line. Well, it's the construction. It's we don't do the digging a hole, putting barrier things. But you know what? As I said, CSM is a risk assessment process. It's very distinctly different to CDM. You can actually apply CSM to CDM risk assessment. Do you see what I mean? You have, so there's no, so inherently we have been doing it for decades since CSM and risk assessment has come about. Because you sit there, okay, your designer's risk assessment, what do? You have competent engineers, whoever knows the project, knows the design, sit down, diligently identify the risk. Well, I know we see a lot of just tripping hazards and things like that, but you will think that on a important infrastructure project, you have these competent people sit down. This is I'm talking about when you're doing your designer's risk assessment as per CDM. You still go through the same inherently. You have been applying the risk assessment process. You identify the hazard, you identify how you're going to mitigate that, you're going to implement that. So you can, that's why you can't actually overlay the CSM process onto your CDM risk management.
Well, CDM principles of prevention and thinking about the impact on an end user is very much in line with CSM, isn't it?
Yeah. So
they're not exclusive, they definitely overlap.
I guess there's overlap, and then the other thing is, so the way that I take it is we kind of don't look at, we want to know the end configuration. Whoa, hello Gary. So we want to know the end configuration is safe. Yeah, if you dig a hole and then the hole is not going to be there next week, we don't really want to know it, frankly. Yeah.
We've got a hand up online.
Okay.
I can't see who it is though.
Yes, Gary, it's me. Can you hear me?
Yeah, I can hear you.
Yes. That was a nice presentation, Oiki. I was just coming back to my question, just related to what you just said when you were explaining, because we have that quite a lot when we work on NPR. Have you ever encountered where the hazard is CDM and CSM at the same time, and how do you deal with it? I mean, in your with your expertise, how would you deal with it? When you got like the same hazard, we fulfill CDM and CSM. So what does it become? Who only? Who had to do the mitigation? Is it the CDM team or is it the CSM team?
Well, if it's something that it impact in the long-term, sort of long-term safety of the system, if it's something that you are going to implement and it needs to be there for good to mitigate the risk of the system, then it has to go in the hazard log, and it is part of CSM. If you say, well, I'm going to dig a hole, there, the hole is quite large, but so I need to put some barrier up. Well, the barrier is not going to be there in 2 months' time once you finish digging that hole. Then that doesn't need to go in, and that doesn't need to be subject to the ASBO assessment, and doesn't need to go into your safety, your system definition. Does it answer the question?
Yeah, it does. So basically, a hazard cannot be both CSM and CDM. It's one or the other. Is that correct?
I would personally disagree with that.
Yeah.
No, I'm asking. I'm just asking the question. I'm asking the question.
I
think some CSM risk assessments would also be CDM. Some CDM hazards would also be CSM. but I can't see any. But there'll be some CDM hazards that aren't
that
CSM.
aren't CSM. Yeah,
Yeah.
that's it. So
Okay.
there are some overlaps, but there are some CDM.
But you're digging a
Exactly,
hole.
the digging a hole. There definitely won't be. But for example, you say, well, because the CDM is all about. It's not just about construction, isn't it? There is a lot of time that we talk about, oh, this is CDM, this is a CSM, because they're making a distinguished difference. You know, they are mitigating the construction risk. But CDM is construction, design, management. You need to produce a design that satisfies CDM. You need to produce a design that you can justify that it can be safely maintained. So these are long-term configuration, isn't it? So that's why I say that's exactly. It's not CDM. What is so a lot of it's easy to think because it's fair to say that Network Rail is a poor. You know, they ban this CDM. You know, they have safety specialist, and because they only look at the construction risk. Yeah. So in the industry, we almost a lot of the time just look at CDM as the construction risk, and then it almost, I don't want to undermine the important work of designers do, but sometimes they inherently do the design safely in their head using the expertise without clearly recording it. That is the difference. Yeah. The only evidence a lot of the time, except for when you take time to produce a safe by design log or things like that, the only safety deliverable that you see from the designers is the DRA. And a lot of them, those DRA is actually not very useful because they only highlight the designer risk. The construction risk. So let's go back to the bridge, there's nothing to stop you because it's a CDM designer risk assessment. Well, the bridge might collapse. So I am going to mitigate it by design it properly to Eurocode, to highway standard, or, so is it a CDM risk or is it a CSM risk? Yeah. So you can actually overlay using the CSM process to mitigate your CDM risk. Yeah. Except for we really don't want to see, the digging a hole sort of things in the hazard record because we have too many entries already. I hope that answered the question.
Yeah, we're T-minus 4 minutes.
Right, okay.
So was there one more question before we
my colleague left, but I believe this is one of the questions you probably want to ask. You said something like the CSM process needs to keep updating during the whole design process, but sometimes we have the problem like the design cycle is like 2 or 3 years.
Yeah.
In the middle of it, the design standard, some of the regular updated. Previously required 3.5, now suddenly goes 3.6.
Yeah.
So is it up to the ASPO to define which standard we should comply to, or as a designer to challenge, like we comply at that point when we have the contract, but we don't, because you say CSM is a long term now.
Yep.
Is it like we need to challenge it, or they have to define which one is to do?
The time at the start of contract, you have design freeze.
All right.
Right. Okay. That's where, unless you get I'm sure you will do, commercial managers, it's a change. So if you change it, if you get, the variation, go and change it. Obviously you need to change it, but if it's not, it's a design change. It's nothing to say that, version 4 was inherently unsafe. They just want to make improvement. But there is a difference is when we talk about the core practice, a law is law. It doesn't matter when it came out. It doesn't matter when you start. I didn't know that, if the project before 2015, it was 2007, but law is law.
And would that apply to national technical rules? So group standards are NTRs. They're part of
the NTSN.
So they got the NTSN, but below that we've got group standards, which are national technical rules.
Yeah, but they are not law, are they?
I'm not sure.
No, they're not. No, they're not. So NTSN is so.
Okay, so yeah, the NTSN is law.
Yeah.
The group standard potentially say 1210 is beneath that, and then it's describing how to comply with the law.
I'm trying to imagine a situation where we're trying to bring a system into service against an old version of a group standard.
The other one would be
Whether any ASBO would in practice accept that.
because the other one would be British standards and stuff like that.
Yeah.
I suppose that's as it's a code of practice.
Yes.
The previous version would still be applicable.
Yeah.
Yeah.
But I guess it really is. It's not really a brush of the ORL is ultimately designed decide whether the project is safe or not, and it's up to the project, mostly probably driven by the client. It's like you said, the electrification project. It's quite it was a long-term project, isn't it? I think I remember, Simon, I think you were there as well. So those OLE screen, what have you, and then they, screening the signal.
Oh yeah, the mesh.
Those mesh, yeah. I think previously you said it's 50 by 50.
It's got smaller.
Yeah, it's got small.
Yeah.
So do you apply or do you not apply, and what do you do? But I think at the time the CSM hasn't come into place yet,
Yeah,
so they got out of it. But that's the thing though. Well, I think it's come from, was it 501?
I think that was about 2010.
Yeah.
That comes from 51 to 2-1.
Yeah, that's it. Yeah,
Yes.
exactly. So that's a really, yeah. So I guess it's really down to what the proposer want to do, and obviously they need the technical authority to guide them. They can't just say, well, due to cost, we're not going to implement a new standard. If they know it's the right thing to do, it's been rolled out because some brainy people have identified, or due to a lot of it is maybe due to there is an accident or there is a flaw in. So it, just yeah. If it's the law, there is no argument. It doesn't matter what it is. We just have to apply at the time. Yeah.
Okay, we need to start wrapping up.
Right, okay.
We're starting to disappear now.
Yeah.
Can we just give a quick round of applause to Mikey stepped in fairly last minute, literally over the last 24 hours. The previous speaker let us down, so really appreciate you coming to do this today. Such a massive subject, and we could probably sit here for the next week and still walk out with questions. I know I've been involved with CSM for 10 years. The one lesson I actually do want to pass on to everybody is engage in this from day one. And if you engage in it from day one, it doesn't bite you in the arse 3 years down the line when you're trying to collect evidence together and fill in a hazard record that is decisions you made 3 years ago. So engage with it from day one and involve the competent people from day one, because the sooner you collect that evidence together and you build it as you go, this could be quite simple, but most projects tend to play catch up.
Yeah.
They get to the end of a phase gate and then they suddenly realize, oh God, I've got to do the hazard record. So yeah, that's just my learning.
Yeah, definitely. Yeah, definitely. Especially when
it's a life cycle.
Yeah, when we used to go to SRP and Jane just sat there and you're like, I can't make this up on the spot, Yeah.
So thank you to everybody online for joining and sticking with us. Brilliant turnout today. Let's hope we start to see more and more people come back into the room, because I think it's a great opportunity to engage face to face with people like Oiki and other presenters. So thank you all for coming, and we'll see you in January. Have a good Christmas.